Bro, you said you did it. You said it.
Okay, dilation is another transformation. You learned transformations last year. You did reflections. You did rotations. You shifted up, down, right, and left. Okay, now we're going to add another type of transformation, which is a dilation. Dilation is a transformation that changes the size of a figure. It can become larger or smaller. But the shape / angles of the figure does not change. To complete a dilation, two things are needed. The first is a center point or a fixed point, which is usually only mentioned when the dilation must be drawn. The second is a scale factor. Or ratio, which is often represented by the variable, not R, but N. That's how we will see it notated in this book. Here you can see how this relates to everyday movie experience. Okay, currently you see my projector projecting. Okay, this is dilation of what's on my screen. It's taking what's up my screen. When it projects it, it enlarges it. Okay, probably by like 10, maybe 20. Okay, so the scale factor would be whatever this, how much bigger this is than what I have on my screen. It doesn't change the dimensions. Sorry, it doesn't change the shape. It's still a rectangle on my screen. The dimensions just got bigger. Does that make sense? Okay, if I moved my projector closer, it would make the picture get smaller. If I pulled it back, it would make my picture get even bigger. Okay, so those right there, that's kind of how it relates what a scale factor is. If you've ever seen like a scale model of a building, Disneyland had this for a while. They had a scale model of, what is it called? A California Adventure of the first one. They displayed it at Disneyland for a while. A version of the large thing to show everybody, all the investors, all the top big wigs at Disneyland, what it should look like. Okay, and if they could change things, they could. Okay, that's exactly what factor and what dilations are. Okay, dilation, scale factor of N, about center C. Is a transformation with a center of dilation and is N, where N is greater than 0. If N is greater than 1, if it's 2, if it's 3, if it's 1, then you're enlarging. It's an enlargement. If N is between 0 and 1, it's a fraction. Third, then the dilation is a reduction. You're making it smaller. Any questions over that? Okay, on coordinate notation, coordinate plane notation, D the N is by the coordinates is here. You have the C, like it's here, then you're in. 0, 0. Any questions over that? Okay. Parallelogram A prime, B prime, C prime, D prime is a dilation with the center of A of parallelogram are the side lengths and the angle measurement related. A, B, C. Okay, how are the sides related or how are the angles related? What did you say? The same angles are the same. Do we remember what the word is when we call something same or equal for geometry? Not similar. Similar means they're kind of alike, but not exactly alike. Not equivalent. Who said it? Congruent. Yes. Angles are the same or congruent. Last year you learned about congruent figures. That means the sides were all the same or all congruent. And the corresponding angles were congruent. Okay, what about their sides? Does someone tell me how their sides are related to each other? No one knows how the sides are related. They're not parallel. They're like overlapping. You guys said it over here. Jacob, you said. No. When you're talking to each other, how are the sides related?
Oh,
Times 2. It's double, right? This figure, A prime, D prime, C prime, B prime, is twice as big as its pre-image. You can tell by looking at this. This side length here, count it, is 1, 2, 3, 4, 5, 6 units. This figure right here is 1, 2, 3. So the side length was increased by 2. I doubled the side length in order to get my new image. Okay, I'm going to show you how to come up with that. That's what we call the scale factor. So the scale factor is equal to the image divided by the pre-image. In this case, you just look at the side length. The side length of my image is 6. The corresponding side length on my pre-image was 3. So the scale factor is 2 when you reduce that. 6 divided by 3 is 2. Any questions over that? Okay. Okay. Okay, the notation. Dilation with a scale factor of 3, that's what this is saying, of triangle ABC means the image of triangle ABC after a dilation center at the origin with a scale factor of 3. Since there's no letter to tell me what point I'm dilating around, you assume it's at the origin. Okay? So basically that means I want this figure to increase by 2. So in order to do that, we want to increase the length, the distance each point is from the origin by 2. Okay. So let's start. We're going to label all these points and come up with the ordered pairs. So B is at -1 and then up 2. -1 for the X and 2 for the Y. C is at 1, 2, 3 for X and up 0. And then A is at 2 for X and then down 1, so -1 for Y. Okay. Our origin is right here at 0, 0. That's what the O stands for, origin. And I want to see how far this is away from the origin. So I have to go up 2 and over 1. Does that make sense? Now I want to make it 3 times as far away. Okay, so I just have to do that same thing 3 times. So I go up 2 and over 1, then up 2 and over 1, then I go up 2 and over 1. And this is going to be B prime. So you can see this distance is 1, then 2, then 3. So this is 3 times as far away from the origin. Does that make sense? Okay. So our new point would be at -3. And then up, oopsie. And then up, 1, 2, 3, 4, 5, 6. And that's B prime. That's our new ordered pair. Does anyone see how those ordered pairs are related? We're going to do the rest too. Yeah, we're starting with this. How are those ordered pairs related? Yeah? I counted, so I went over to the X value, which is at 3, and then I counted up 1, 2, 3, 4, 5, 6. That's how far up I had to move. No one sees the relationship there? Very good. All I did was take the original and multiplied each of the coordinates by 3. The X coordinate, -1 times 3 is -3. 2 times 3 is 6. This only works when it's being dilated about the origin. If it's dilated about a different center point, then it will not work like that. You won't see that same relationship. Let's try with A now. Oh, let's try with C. C, I just have to go 3 away. I'm going to go 3 away 3 times. So I have to go 1, 2, 3, 1, 2, 3, and it's going to be way off my graph, right? So I can just take the C and multiply it by 3. So C prime would be at 3 times 3, which would be 9. And 3 times 0 is 0. So I just take the coordinates of the ordered pair and multiply them by 3. Any questions over that? We're all good? Okay, let's try A. A, I'm going down 1 and to the right 2. Okay, and I'm going to do that 3 times. You're going to go down 1 and right 2, down 1 and right 2. And this would be A prime. And so that is 3 times as far away from the origin. That's why we have a dilation of 3. For the ordered pair, the same thing. I'm going to do A. A prime is going to be 3 times the ordered pair of 2, -1. So A prime would be at 6 and -3. Any questions over that? Pretty easy? Okay, if we could find, if that C could be on there, then we would draw the picture. Unfortunately, we can't find, this is way over here at 9. So we can't finish drawing it. Okay, next one. Okay, what are the vertices of a dilation by 1/2 with a center of R of QRST? So we want to dilate this by 1/2. Okay, so is our shape going to get bigger or smaller? Smaller. I'm going to cut it in half basically. And here's my center points right here. So step 1, find the length of RQ. Okay, so when I look and see how RQ is 1, 2, 3, 4, 5, 6, 7, 8. So RQ equals 8. Now we're going to multiply RQ by 1/2. So R prime Q prime is going to be 8 times 1/2. So half of 8 is 4. Okay, so we're now going to graph that point. We need to be 4 away from R. So 1, 2, 3, 4. And that's going to be Q. Q prime. Okay, step 3 is to repeat. With RS, segment RS. Okay, so you guys find the same thing. Find where S prime should go. Okay, RS was 6. So R prime, S prime should be at 3. So this is S prime. From there, hopefully you can see where the T prime should go. And so now I have my new image. Any questions over that? Okay, then it asks us to find the vertices. So we're just going to label all those vertices. R didn't change. When you are dilating about a point on the figure, that point doesn't change. So we're at -2 for X, and 1, 2, 3, 4, 5, 6, 7 for Y. Then S prime is at 1 for X, and then 7 for Y. Find the next two, Q prime and T prime for me. Find the first one you should draw on the figure. Thank you. Okay, Adrian, did you get S or no, Q prime? Very good. -2 and 3. And then Logan, did you get T prime? Very good. Any questions over that? Okay, now we're going to apply this. Okay, we have a blueprint for a new library using a scale factor of 1 to 50. Mr. Iyer measures the reading space on the blueprint to find actual dimensions and areas so he can order furniture. What are the actual dimensions of the reading space? Okay, so any architect is going to draw the blueprints, and it's going to be a smaller version of the larger building they're going to build, or a house or whatever. Okay, and they use a scale factor, and it's usually written on the blueprints itself. Okay. So here we just need to see what the blueprint dimensions are, and hopefully you guys can read that. This is from 0 to 14, so this is 14 centimeters. Okay, so the length of that side is 14. Okay, then we want to find the length of this side. Do you guys see what that is? 12 centimeters. It should be smaller than 14, right? This looks a little bit longer than this side. It's 12 centimeters. So it's 14 by 12. Okay, it has a scale factor of 1/50. Okay, so what do we need to do to those dimensions to find what the actual room's dimensions are? Any ideas? Okay, tell the person sitting close to you. What do you think you should do? So you're not so nervous to talk. Tell them. Any ideas on how we're going to find the larger dimensions? Okay, Maddie, what did you guys' group say? Very good. Our scale factor is 1/50. So that's how small the blueprint is. So to make it bigger, we'd have to multiply by 50. Okay, so we're going to do 14 times 50 by 12 times 50. Okay, 14 times 50, that became 700 centimeters. By 12 times 50 is 600 centimeters. Okay, so that seems really big. Centimeters should actually be more to meters probably. So 7 meters by 6 meters. Okay, now the actual area, what is the actual area of the reading space, and how does the actual area relate to the area on the blueprint? So we need to remember what area is. Anyone remember what area is? How do we find area? Length times width. Ooh, thank you. Who said it over here? Amir again? No? Who did? So write that down. Area equals length times width. Or you might have done base times height. However you want to say it. You might do. So the area of our actual figure equals 700 times 600. 7 times 6 is 42, and then we have 1, 2, 3, 4 zeros. 1, 2, 3, 4 zeros. So 420,000 centimeters. Oh, and centimeters squared. Now they want us to compare it to the area of the blueprint. So we need to find the area of the blueprint. 14 times 12. is 168 centimeters squared. Okay, so how are those related? Talk to each other and tell each other what you think, how those are related. Check, use a calculator, see if your predictions is correct. And here's some of the similar things. How are they related to each other? Okay, did anyone come up with how you think they're related? Yes. Oh, good. And quiet down, please. So Amir found that if we divided these, we got 2,500 or 2,500. Some of you have heard you saying, oh, I think it's multiplied by 50. No, it's multiplied by 2,500. Anyone know how that's related? 50 times 50. It's 50 squared. Okay, when we increased the side length, did we just increase one side length? Did we only multiply by 50 once? No, we multiplied by 50 twice, right? So when I find the area, I have to multiply 50 times 50, which is 50 squared. So the area scale factor is going to be the scale factor squared. So the area is increased by 50 squared. And that's how all areas will be when you're dealing with scale factors. Yes. So have you ever had to figure out how much paint you would need? Okay. You can still use the scale factor to find that. Okay, so now we're going to learn how to draw a dilation. That's the figures with the given center and given scale factor. Let's see if I can. Sorry, I'm trying to figure out how to switch this really fast.